We're going to, again, work with a system of inequality equations, find the solution region, determine if it's bounded or unbounded, and find the corner points. This time we're working with the equations x plus y is greater than or equal to 2 and 2x plus y is greater than or equal to 3. Notice again that both x and y are greater than or equal to 0, so we know the solution region must be located in the first quadrant because that's the region where both x and y are positive numbers. We take x plus y is equal to 2, write that in the form of y equals mx plus b, so y is equal to negative x plus 2, telling us the slope is a negative 1 and the y-intercept is a positive 2. Looking at 2x plus y is equal to 3, writing in the form of y equals mx plus b, we have y is equal to negative 2x plus 3, telling us the slope is a negative 2 and the y-intercept is a positive 3. Now, step 2, we want to be able to graph these lines, so we want to be able to write a system of groups of ordered pairs that will satisfy the conditions of the equation. Again, since I know that it has to be in the first quadrant, I'm going to start off with a negative 1, 0, and 1. And now I'm going to scroll down to a positive 6. I want to be able to find the corresponding y values, setting up the equation. Y is equal to the negative 1. Make that a fixed cell. Remember, on a PC, you go to the function buttons, which is the top row on the keyboard, F4. On a Mac, you either press Command T or plus T, times the x coordinate, in this case is negative 1, plus the y-intercept, which again must be a fixed cell, in order to be able to find the corresponding y value. And we scroll down and we get all the corresponding y values for x from a negative 1 to a positive 6. The y goes from a positive 3 to a negative 4. Using those same values, I'm going to copy for the x coordinate for the equation 2x plus y is equal to 3. We're going to set up the formula in order to be able to solve for y. Remember, setting up a formula, we always type on the equal sign. And we have the slope, which is going to be a fixed cell, again, F4 or Command T, times the x coordinate, which is a negative 1, plus the y-intercept, which has to be a fixed cell, again, F4 or Command T. Again, when x is equal to a negative 1, y is equal to a positive 5. Scrolling down to copy the formula to get the corresponding y coordinates from x is a negative 1 to a positive 6. Goes from 5 to a negative 9. Now we want to find the graphic representation, so I'm going to highlight the x and y coordinates for x plus y equals 2. We go to Insert. We want the chart to be a scatter plot, and I want to see the points, and I'm going to bring that down below the line. So bear with me while I get there. Okay, and now we can see what the graphic representation looks like. I'm going to make that a little bit larger so we can actually see the line. Okay, give me a moment so I get that down. And we now see the graphic representation of x plus y is equal to 2. Remember, we want to add the other line to this chart area. So we right-click, and sometimes you have to do it twice. We go to Select Data, and the template comes up. And the first thing, again, I want to be able to see the inequality equation. Instead of y, I want to see the actual equation, which says x plus y is greater than or equal to 2. I don't have to change anything else. I press OK. And now I want to add the second equation, which is 2x plus y is greater than 3. I want to include all of the x coordinates. Go to the third window. Again, we are going to make sure there is nothing in there. And we have the y values, which goes from a positive 5 to a negative 9. We press OK, and we look at the inequality equations. And now looking at our graph, this is what the graph region looks like. In order to be able to look at the lines in their inequality format, I go to our legend, and you notice the legend comes up right away. And we notice that since x plus y, which is the blue line, is greater than or equal to 2, we are going to the half region above the line. Very similar for 2x plus y, the orange line is greater than 3. We're going again above the line. Therefore, in this case, we have an unbounded region. Now, what we want to do is we want to shade the area. So again, we're going to go to Insert. We're going to go to Illustrations. We go to our shapes, and we're going to go to Free Form. And I'm going to start the plot area on the y-axis. My lines don't go so straight. I want it parallel to the orange line. Then I want it parallel to the blue line, and I want to make sure I don't go below the x-axis. I'm going to try my best to get it there, and we'll see if I worked it out. And that basically is the region, and I want it to look a little bit cleaner, and I'm going to move this up just a tad. So we see that the region is unbounded. It's definitely located in the first quadrant since x and y have to be positive, and we want to be able to write down the corner points. Now, looking at the corner points again, for the 2x plus y is greater than or equal to 3. We have the y-intercept, which is at the ordered pair 0, 3. We go down to the point of intersection of both lines, and we can read that clearly. We have the ordered pair 1, 1. And basically, that's it. Those are the only 2 points that have our boundaries for this unbounded region. So we have this particular information, and now we have an unbounded solution area as well as the previous video, which was a bounded solution region.